All right, Algebra 1, lesson 55, solving systems of linear equations. Let's see, I've got about 14 minutes, something like that, 14, 16 minutes. We'll see how much we get through. Solving systems of linear equations. This means we're getting more than one linear equation. The solution to two or more linear equations are where the lines cross, or place it, or even defined otherwise, are the coordinate locations where that x and y number is a solution to both equations. Okay? So a system of linear equations consists of two or more linear equations containing two or more variables. An example shown below is 3x plus y equals 9 and x plus 2y equals 8. These are linear equations even if they're not in slope-intercept form. Could we convert these to slope-intercept form? Yeah. Okay, we could convert those to slope-intercept form. Once we converted them to slope-intercept form, could we graph them? Yes. All right, the solution on the graph of two linear equations are where those two lines cross at. Okay, so that's visually where we would see the solution at. Algebraically, it would be where we would find the solution for x and y given both those equations. So a solution of a system of linear equations is any ordered pair that makes all the equations, two or more, correct or true. A solution to a linear equation can be found on a graph like we've discussed, where we graph each equation and then we solve a system of linear equations. If the system has one solution, the solution is the common point or the point of intersection. It is possible that there is no solution to two or more linear equations. There's no solution when two lines are parallel to each other, because are two parallel lines ever going to cross? All right, so there's no point of intersection, therefore there's no solution. All right, we could also have infinite solutions, and that's the case whenever two lines turn out to be the same line. Okay, if two lines overlap each other, how many places do they cross at? How many? All right, let me draw a line here. Let's say we've got a coordinate plane. Okay, and I've got this blue line here. All right, let's say, and then so I've solved that. Right, I had an equation. I graphed it. It looked like that. Then I got another equation. I solved it for the slope-intercept form and graphed it, and it turns out that it had the exact same slope and y-intercept. How many places do those two lines cross at? Not only does it cross at any point, it crosses at every point. And how many points are there in a line? A lot. In fact, what is a word for a lot? Infinite. An infinite number of solutions. All right, so when two lines are the same line, we say that they have an infinite number of solutions because everything I plug in for x and y is going to fit either one of those two. Okay? All right, so there are given two or more systems of equations, there are three possibilities. They either have one solution, no solution, or infinite solutions. Okay? And that's it for what they give you there. So let's take a look here. Okay, so question number 1 says, tell whether 2, 7 is a solution of this system of equations. Okay? Now, really these are inequalities. So let's look at this. Tell whether 2, 7 is a solution. Well, let's look at the first one. What would I do with this 2 and 7 in the first equation? Substitute. All right, what do I substitute in for y? 7. Let's try this. 7, all right, is greater than or equal to 4 times what? 2. Okay? Is 7 greater than or equal to 8? No. right? So it doesn't work there. Is 7 less than 2 plus 2? Is 7 less than 4? No. So what is our answer? A. No. 2, 7 is not a solution to this system. Okay. Let's take a look here. Okay, this says solve the system by graphing. Well, if I'm going to graph this, what might I want to do with 3x plus 4y equals negative 36 if I wanted to graph that? Exactly, change it to slope-intercept form. How do I change an equation, a linear equation, into slope-intercept form? What do I want to solve for? Solve for y. Yes, thank you, Caden. Right, that was Caden, right? Sometimes I hear, it's just from back there, my hearing's terrible, so it's either Blayton or Caden at any one time. So if I hear a voice from back there, I'm just going to split the difference, right? Half the time I'll congratulate Caden, the other half I'll give Blayton the credit for. All right, so we want to solve for y. All right, so we have 3x plus 4y equals negative 36. Caden, how would you begin to solve for y? What's the first step you would do? Perfect, get y by itself. So we need to get rid of that 3x and that 4. What do you want to move first? Perfect, the 3x. How do I get the 3x to the other side? Perfect, 3x minus 3x minus 3x. I'm going to rewrite that. So it's 4y equals what? Perfect, very good. All right, now you want to get rid of the 4. How do you get rid of the 4? Divide it on both sides. Excellent. Divide it by 4. So I get y equals what? Minus, what's 36 divided by 4? Negative 9. All right. So we could probably even go ahead and graph that one, right? Right? So what's the y-intercept on that? Negative 9. And what kind of slope does it have? Negative slope is where it's going to go down 3 over 4, right? So you would have a y-intercept somewhere right around in here, right? But I can't really go down any further. So could I go up 3, back 4 and plot a point? Yeah, I can. You know, to get further to the left, I could do the reverse, right? So if I'm at 9, I want to go up 3. I would go, what, up to negative 6 and back 4, right? So that would put a line about there. If I wanted to go up another 3, back another 4, so that'd be about here, something like that. And I would get a line that looks similar to that, right? Okay. All right, so I'm going to, we'll leave this, and somebody else help me out with fixing up negative 2x plus 4y equals negative 16. Somebody besides Caden. Okay, Abby? Perfect, add 2x to both sides. Okay, so you have 4y equals what? 2x minus 16. What's your next step? Divide both sides by 4. Okay, so you're getting y equals what? Can we simplify 2 over 4x? 1 half x, maybe? 1 half x, good. Minus what? Minus 4. Okay? 1 half x minus 4. All right, so what's the first thing that you want to plot? What's the first thing I want to put on the graph given that equation right here? The negative 4. So that's going to be, was that Abby you said that? No? But do you understand it? Okay, so I'm going to put a point at negative 4 on the y-axis. Where do I want to go from there? What's my slope? Abby, you can look up here. Your answer is up here. What's the slope of that equation? So I'm going to do what? I'm going to go up how many? Up 1, down 2? No. Up 1 over 2. So up 1 over 2, up 1 over 2, 1 over 2, 1 over 2, something like that. But if I want to see where they cross, I need to go back the other way. So I'm going to go down 1, back 2, down 1, back 2. So do we see where they cross at? Okay, we see a point of intersection. What is that point of intersection? Remember, we use x value. What's our x value there? Negative 4. And what's my y value? Negative 6. So we can't see it here, but B has the right coordinates, and it's the only one that has those coordinates, right? Okay, so if I clear out some of this, does that match our graph that we should have gotten? Is B? Yeah. Okay, so do we understand how to solve a system of equations by graphing? Yeah. Now, what's really nice at the Algebra 1 level with their homework and everything is that those points of intersection are probably most of the time going to be nice, neat little coordinate locations. As you get into upper level math, you're going to find that sometimes they cross at not so nice places. All right. Let's see. There's 6 questions, but we're about to run out of time. Is there a question from your homework that you would like to see before the bell rings? Okay, for lesson 55. Don't guarantee that we'll get through it in 4 minutes, but all right, so C says solve the system by, solve the system by graphing, then check your solution. Okay, so checking your solution means to actually plug those x and y values back into the equation and see if it is a solution. Let me see if I can come back here. Okay. So on, like, let's say C, right? Notice how it's y equals 2x minus 5 and y equals x minus 3. Okay, now you're going to have to solve that by graphing. So you're going to get graph paper is what I prefer that you get. There's graph paper back there. Before you leave, you might want to grab some. Okay, don't just make a graph on your notebook paper because you're not going to make your tick marks evenly spaced and they're going to be off a little bit or whatever. Okay, so here we would be at 1, 2, 3, 4, 5. So we'd have a dot here, right? We'd go up 2. Okay, then we've got, what, negative 3. And then we're going to go up 1 over 1, up 1 over 1. So we see that this coordinate here, which is 2, negative 1, appears to be the solution, right? We see that by graphing because it's the point where both of them meet. Yes? Okay, and you're going to draw a much better graph than that. Okay, but then it says check that solution. So what I'm going to do is I'm going to come up here to the first equation. I'm going to say negative 1 equals 2 times 2 minus 5. All right, well, what's 2 times 2? 4. What's 4 minus 5? So does negative 1 equal negative 1? Okay, that works. All right, here I'm going to do that same thing in this next one. I'm going to say negative 1 equals 2 minus 3. Well, what's 2 minus 3? So negative 1 equals negative 1 again. So this is me doing what the question asked, which is I solved the system by graphing, and then I checked my solution. Do I need to do both those things so that Mr. Wilcox doesn't hand my paper back to me and says, hey, you didn't follow the directions, you're going to have to redo or fix a bunch of these? Okay, so make sure you're reading the directions so that you don't get your paper handed back. Okay? Can we do those? Does that help? All right. let's stop there.